X and Y intercepts. So this is 1.4 video 5 with audio this time. Apparently the audio didn't record the last time or something went wrong with it. So hopefully I remember everything that I said in the last video. I'm going to do my best. Alright, so we're looking for X and Y intercepts, which again should be a concept you're familiar with. You should have somewhere along the line found X and Y intercepts. They're very important. It's very important that you know how to find them. In a lot of applications, the y-intercept's where we start and the x-intercept's where we end. Not always, but a lot of times it is. Or often we want to find the x-intercept. X-intercept is a very important part of our graph that we want to find. So finding these are important. They also help us graph, right? They're really easy points to find and they help us get a good picture and graph. All right, so the first one is the y-intercept. The y-intercept is the point in the graph where x equals 0. So I plug 0 in and I get the point 0 some y value. 0 y naught means the initial value for the y. When I plug 0 in, I get that y value out. And so again, you let x equal 0, you solve for y. You plug 0 in your function and solve for y. All functions, in order to be a function, have at most one y-intercept. There's only one place where it crosses the y-axis, right? That's what this happens is when I cross the y-axis. I can only cross the y-axis at most one time, right, because it's a vertical line, if I'm a function. I can have the case where it doesn't cross it at all, so I can do one or none. Right? It either crosses it once exactly or none. There's 0 times it crosses. But again, that's the y-intercept where it crosses the y-axis. The x-intercept is the point on the graph of the function where the y value is 0. Right? The y value is 0, and so it's the point some x value where the y value is 0, and so this is where it crosses the x-axis. Right? And my x value is where it crosses and my y value is 0. And so you solve it, you let your y value be 0 and solve for x. And you'll notice here that I've said the y value is the function value, right? And so it's when the function value is called 0, right? The function set equal to 0. And so that is why oftentimes we'll say find the 0 of the function. The 0 of the function is the x-intercept. It's where it crosses the x-axis. It's when my function, the y values, are 0. Right? And so the 0 of the function is oftentimes we ask for that, and it means the same thing as the x-intercept. Right, so the 0 of any function is some number x. Right, x equals c. C would be a number. When I plug that number in, I get 0 out. It's called the 0 of the function for that reason. Graphically, it is the x-intercept. You set your function equal to 0 and solve for x. Right? It's your x-intercept. What's interesting about the x-intercept is when you find your zeros, which again are your x-intercepts, it's interchangeable. Find zeros, find x-intercepts, same thing. Is you can have more than one x-intercept. It can cross the x-axis more than one time. Cross it once, it can cross it twice, and actually there are some cases where it crosses it infinite many times. Or none, right? There are graphs where it's completely above the x-axis or completely below the x-axis, and it never crosses. Alright, so x-axis allows us for more possibilities. You can have 1, 0, or multiple x values where I cross the x-axis. So multiple places where my function is 0. Alright, so now we're going to practice graphing some lines using the intercept and slope and finding our intercepts. Alright, so graphing lines and finding intercepts. So the first one wants us to find the linear function mx plus b that satisfies the given information and then graph the line. So we're just asked to find our function and graph it. We're given the slope and we're given the y-intercept. So remember, slope is the m part. Y-intercept is the b part. And so our function, in this case, is just simply 3/4 x plus 4. There's our linear function. And now the graph. And I'm going to use, this is why the y-intercept's nice. I'm going to use the y-intercept and the slope to graph. Alright, so I'm going to start with the point 0, 4. And then I'm going to use the slope, negative 3/4. So remember, negative 3/4 would be the change in y is negative 3. The change in x is positive 4. And so I'm going to use that. Alright, rise and run. I'm going to use that rise and run when I go to graph. Alright, so graphing my line. There's my y-intercept. There's my x-intercept. Or x-axis, not intercept. And so the first one is to graph my intercept. Start here at the 0, 4. So 1, 2, 3, 4. So there's my point, 0, 4. And then I'm going to use my change in y. Now you can just find another point if you want to, and that's fine. But I'm actually going to use my slope to do that. I'm going to find my change in y and my change in x. And so the change in y is a negative 3, which means I'm going to go down 3. So I'm going to start here at that 0, 4. I'm going to go down 3. So 1, 2, 3. And then I'm going to go over 4. It's a positive 4, so I'm going to the right 4. So 1, 2, 3, 4. And so that puts me there. And so the point that I've moved from when I went down 3 over 4 is the point 1, 4. Now if I want a second point, the third point, so there's 2 points. You really only need 2 points to graph, but I do believe the homework might ask you for 3 points. And so to find the third point, we'll just do that again. All right, go down by 3, so 1, 2, 3, and then over by 4. 1, 2, 3, 4. So down 2 over 4 puts me at the point 8, 2. And there's a third point, and then I just connect the dots. And you can always check your answer. If you're unsure with the arise over run, we'll plug them in. Is f of, and I did my point backwards here, should have been 4, 1, so make sure you change that. This should be 4, 1, right? X value 4, Y value 1. And if I checked my answer, I would have found out that was the right case, right? So if I plug 4 into my function, so I go up here and I plug 4 in, f of 4, well, those cancel out, leave me with negative 3 plus 4, which is going to give me 1, and so that does check. And the same thing with 8, 2. I can do the same thing. I could plug 8 in for x. I should get 2 out for y, negative 2 out for y. And so the 4 reduces into the 8, leave me with 2. And so I get negative 6 plus 4, and there is my negative 2. And so it is that point, and again, I left my negative off, 8, negative 2, 4, negative 1, and there's my 3 points to graph my line. All right, next example. Given a linear function, find the slope, the 0, the y-intercept, and graph. So I'm asked to do 4 things. I want to know what the slope is. The 0 is, remember, 0 is just another way to say x-intercept. The y-intercept and the graph. 2 of those are really easy, right? This is f of x equals x minus 4. In front of the x, it's understood that there's a 1 there, so my slope is 1. All right, have the slope. The negative 4, well, that's my b, that's my y-intercept. So I have the y-intercept 0, negative 4, my y-intercept. Alright, so I have the slope, I have the y-intercept. The only thing left for me to find is my 0 and then graph it. So I'm going to find my 0 next, remember, is just my x-intercept. We call it the 0 because it's when the function equals 0, right? I set my function equal to 0 and solve for x. So take my function, x minus 4, set it equal to 0 and solve for it. So this is pretty simple. I just move the 4 to the other side. And so x equals 4. So my 0 is x equals 4, which is the point for 0. And that's what I'm going to use to graph it, right? I'm going to graph those 2 points on my line. So I'm going to come down here and I'm going to graph. So there's my y-intercept, y-axis, x-axis, and I'm just going to graph my intercepts. Alright, so my y-intercept is 0, negative 4. So 0, negative 4 puts me down here. X-intercept is positive 4, 0, so that puts me there. And then connect the dots. And there's the equation of my line, where I found my intercepts. Right, the next one, so I'm going to write down here, so I'm over to part B, is f of x equals negative 6. And so this is one of my special lines. Right, this is the line y equals negative 6, which is a horizontal line. Alright, horizontal lines, slope is 0, and then the y-intercept, well, the y-intercept is 0, negative 6, right? The y values have to be negative 6. there is no x-intercept. And we'll graph it and I'll show you why, so there's no 0. So remember, a horizontal line is the line y equals 6, so all of my y values are negative 6. So here's my y-axis. Here's my x-axis, 1, 2, 3, 4, 5, 6, negative 6. So there's the 0, negative 6. All of my y values on this line are negative 6, right? There's the y equals negative 6. If I pick any other point on my line, 2, well, 2, negative 6. Alright? 1, 2, 3, 4, 5, 6, 7. That would be 7, negative 6. That would be a third point. So every single point on that line, the y value is negative 6. The x value is anything. If you'll notice, it's parallel to the x-axis, therefore it never crosses the x-axis, which is why there is no 0. Y can never be 0. Y cannot be 0. It always has to be negative 6. So there is no 0. The function never equals 0. It never crosses the x-axis. Alright, next examples are given a graph. Alright, so given a graph of the line, find the slope of the line, interpret it, find the intercepts, include the 0, and the equation of the line. Alright, so we'll start with if we can find our intercepts. Alright, so my y-intercept looks to be there. My x-intercept looks to be there. So x I can't find, but y I can. Y is at the point, so my y-intercept is at the point 0, 5. X-intercept I'll have to find after I find my equation. So the next thing I'm going to do is find my slope. I'm going to find my change in y over my change in x. And so basically just kind of look for another point that shows up on my line. So this looks like a point where it hits here. There also is one here. You can use either one of those. So I'm going to use the one up here where it looks like it hits it at 1, 9. If you wanted to use this one where it looks like it hits it at negative 1, positive 1, you could use that one as well. Negative 1, positive 1. Alright, so my change in y, if I do my change in y, well, I'm going to go up here, so up here to 9, and then my change in x would go over 1. And so I'm going up 2, 3, 4, so I'm going up by 4, over by 1. So my change in y is a positive 4, my change in x. And I'm going to check just to see if the other point works the same way. If I start here at 1, 1, I'm going to go over 1 and up 4, right up to 5. And so it also is my change in y. I'm going up by 4 and over by 1, and so my slope is 4. Okay, so my y-intercept is 5. And so that means the equation, right, f of x equals m, which is 4, x plus b, which is 5. So there's the equation. Alright, so find the slope, interpret it. I haven't interpreted it yet. Find the 0 of the function and the equation lies. So I still need to interpret my slope and find my 0. Alright, so I'll interpret my slope first. So slope was 4, and so what the slope of 4 means, it was 4 over 1, it means the function, right, the line, is increasing by 4 units per change in 1 unit of x. Right? And x goes up by 1 unit, y goes up by 4 units, so it's increasing. Right, now the 0, which is better known as the x-intercept. And I can kind of ballpark it. I know it lands somewhere between -2 and -1. Looks like it's a little closer to -1. So I know it's going to come out negative. And so to find it, well, I take my function f of x and set it equal to 0. And so 0 equals 4x plus 5, and then solve for x. So subtract 5, so I get -5 equals 4x, divide by 4, divide by 4. And so my 0 is x equals -5/4. And it is between -2, it's -1 1/4, right? So it's close to -1, and so there is my 0. It crosses at the point negative 5/4, 0. Alright, so there's the 0 of that function. That would be this moment here, right? And that moment there would be at negative 5/4, 0. Alright, next example. Alright, this should be a negative slope, right? It's moving the negative direction. Actually, this one looks like I have both intercepts, right? The y-intercept looks there, the x-intercept looks there. So my y-intercept looks to be at the point 0, 2, right? My b is 2. X-intercept, which is my 0, looks to be at 8, 0. So my x-intercept is 8. 0.80. My slope then, change in y over change in x. So again, if I use my change in y, I'm going to go down 2, right, negative 2, and over 8. So down by 2, so it's a negative 2 over 8, so negative 1/4, right? It should be a negative, and it is negative 1/4, or negative 0.25 if you prefer. Which is probably the way we were going to describe what the slope is. Alright, so my function is f of x equals my slope negative 0.25x plus, not plus, it is plus 2. Alright, so there's the equation. So again, I found my x-intercept, my y-intercept, my slope, and my equation. So the last thing is just to describe what slope is telling me. Alright, so slope is telling me, there's two ways you could do it. You could use the original 1/4, but a lot of times we want to describe it in terms of 1x unit. So I'm going to use the 1x unit. And so the slope that I'm going to use to describe is negative 0.25. And so first of all, my function, f of x, is decreasing by 0.25 units, a quarter of a unit, per change in x. In 1x unit. So per change in x implies 1x unit. So I'm moving down by a quarter of a unit every time I increase x by 1. Alright, the last example. Horizontal line, right? I'm down here at my horizontal line. And so it's actually probably easier to find my line in this case. Every single point on this line, my y value is negative 3. Okay, so this would be the point 0, negative 3. This would be the point negative 2, negative 3, and so on. And so that means the equation of the line is y equals, or my function equals, negative 3. It's the constant function. Negative 3 is always coming out. Means my y-intercept is 0, negative 3, right? B is negative 3. There is no x-intercept. It doesn't exist. No 0. Never crosses my x-axis. Slope, right? My slope is 0. Flat line is 0, right? 0 slope. And so the 0 slope is actually important. It's important that we understand what a 0 slope is, right? When my slope is 0, it means f of x is constant. Meaning it is not increasing or decreasing. It's staying the same. It's always negative 3. It is not moving up nor moving down. It is flat. It is staying constant. The whole time it's negative 3. I'm never changing from that. So it's not changing. So another way to say it is there's no change. Always negative 3. Alright, so there is now a video of 1.4 about x and y intercepts with sound. Hopefully it worked this time. I'll still probably leave up the other video, but I'll post this one as well.